Hey, welcome back to another Genetics 311 exam video. Today we're going to be going over developmental networks. A developmental network is a pathway that describes the network for phenotypical traits in an organism. The original prompt was for a dragon with the spike trait. However, to make it more interesting and to celebrate the new season, I will use Mandalorian characters to describe this pathway. In The Mandalorian, the characters Queel, IG-11, Kara, and Mando are trying to help Baby Yoda get back to his people. Characters like the client are doing everything they can to stop that from happening. The key to translating between the characters and the original problem is shown above on the right. For the wild type of this sequence, Baby Yoda would be successful in returning to his people because Queel would be able to produce the IG-11, which would inhibit the client from preventing Kara and subsequently the Mando from helping the child. If something were to happen to IG-11, where it was no longer part of the plot, the client would not be inhibited and thus inhibit Cara Dune, which would not allow the Mando to help the child. Therefore, the child will not be returned to his people. If the client were not in the picture, the Baby Yoda would be returned to its people successfully because nothing would be inhibiting Cara from producing Mando to help the baby. In the event that Mando and the client were not in the picture, the baby would obviously not have a chance at being returned to its people because without Mando, there is no Baby Yoda. The client being successfully removed is essentially useless if Mando is not present. Lastly, if Queel and Cara Dune were removed from the plot, the baby would have no chance at returning to its people because Cara must be present for Mando to have a chance at returning the baby to his home. For the last section of this video, it will be better to talk about the prompt with the original problem in hand, talking about dragons and spikes. The question asks why not all cells in the skin have spikes, even though they have the exact same genome sequences. This can be explained by DNA methylation in some skin cells, but not in others. DNA methylation is essentially when a sequence of nucleic acids is mutated and has a methyl group added to it. This will silence some phenotypes, leaving them unexpressed in the organism. Since methylation is a mutation that occurs on a cellular level, this can happen in one cell, but not in the other cell. Typically, this will occur in a nucleic acid sequence that will have cytosine paired with guanine. In the event that the cytosine is methylated, that sequence will be mutated because the methyl group will silence the phenotype in the organism. Thanks for watching, and my references will be in the description box below and at the end of the video.